Well, we've had a lot of fun together, haven't we? We've gone through the gamut of learning about what natural language processing is and how deep learning applies to it and can do natural language processing so efficiently. We learned about word vectors. We created our own word vectors. We use those word vectors and vector space embeddings in a series of deep learning models involving old layers that we were familiar with from the previous live lessons, as well as some new layers that were introduced in these live lessons. And in the very last segment, we developed an architecture with parallel columns of convolutional layers, and this proved to be a powerful approach to getting sentiment reviews. Now, there is one last thing that merits our attention before we move on. So, at the end of the last live lessons, I talked about tuning hyperparameters. And so I want to bring back the list of hyperparameters that we talked about tuning from those live lessons, and then we're going to add to it today, because these new architectures that we've been working with, particularly the vector space embeddings, have lots of additional parameters that merit our consideration. So the 10 hyperparameters that we talked about in the previous live lessons were getting above chance. So this was simply the idea that until you have some kind of learning happening in your network, even on a simple problem, there's no chance for tuning hyperparameters and making that network better. The second thing is changing the number of layers or the types of layers, the breadth of layers, and now, given what we learned in the most previous lesson, we can also stack layers side by side, not just vertically, and then concatenate those together. It's important to initialize your network properly. You want to be using either Glorot uniform or Glorot normal. You want to be considerate with your cost, probably using cross entropy, binary or categorical if you're solving a two-class or a multi-class problem, for example. You want to avoid overfitting in your network, so adding in regularization, playing around with the dropout and the proportion of neurons that you're dropping out, expanding your data set, even artificially if you can. The step 6 here is adjusting your learning rate. So that's your learning rate and your gradient descent, including considering using second order approaches like Atom. You want to be looking at the number of epochs that you're training for and stopping early if necessary. You want to tune your regularization parameter lambda for the L1 and L2 regularization if you're using that in your network. And you want to tune your batch size. So mini batch size can end up being a surprisingly important hyperparameter to get right. And then, of course, there are also options for automating. So I talked about spearmint in these last live lessons. So you can use spearmint to automate your search over all of these various hyperparameters. Given the additional layers and concepts that we've introduced in these live lessons, there are some additional considerations that are worth looking at as well. So I brought up the last notebook that we built here, where we had our multiple parallel convolutional nets concatenating together, which gave us great results on the sentiment analysis task. And so let's just have a look through here at the additional hyperparameters that merit your consideration. So now we have the number of dimensions in your vector space embedding to consider. I tend to adjust these by powers of 2. So I might experiment with having the number of dimensions in my vector space be 32 or 128, 256. If you're working with very large data sets, then having several hundred or even considering 1,000 or more dimensions in your vector space can be worthwhile. With smaller data sets, 64 or 32 should be plenty. taking into consideration the number of unique words will give you different results. Also, potentially removing the most frequently occurring words or removing stop words can make a big difference to the end result in your particular downstream natural language processing task. If you are reading in documents, then the length of those documents can make a big difference. So you're going to be padding short documents or truncating long documents so that they all have the same length. And that particular length is going to make a difference. Recall that if we're using LSTMs, because of the vanishing gradient problem, we probably want to not have more than 100 words in a given document. If we're using bidirectional LSTMs, then we can probably have 200. We also need to make a decision if we are padding and truncating. Where are we padding and truncating? Are we doing it at the beginning or the end? For different types of documents, there might be, on average, more important information in the beginning or the end that we don't want to be truncating, for example. And so that is another hyperparameter that merits your consideration. We have dropout in a number of places, including in the embedding layer, and then also in our hidden layers. So lots of hyperparameters to consider. There are a universe of possibilities of ways that you could end up adapting your grid search. The good news is that neural networks are so robust that many of these small changes won't make a huge difference. If there are enough neurons available to be learning the weights and biases, then maybe not all of your neurons will end up getting used, but typically your network will converge on an optimal solution one way or another. Excellent. It's been great sharing these lessons with you. See you again next time.